Algebra 2. Hope you guys are having a great day. Today we're going to take what we know about quadratics and do similar things with inequalities with quadratics. So an inequality is basically an equation with an inequality sign. Less than, a greater than, or a not equal to sign. Right, so we've always done things with equals signs, but this time it's going to be inequalities. So just as a quick refresher, basically you solve it exactly the same way you solve it as something with an equal sign, right? Except, let's put in our equal sign, except when you multiply or divide by a negative number, then you switch the sign of the inequality. So if it's this alligator, then it switches to this alligator if you multiply or divide by a negative number. Okay, so solving is pretty simple, right? The hard part is really graphing it and figuring out like where your solutions exist. So we're going to encounter two different types of problems. We're going to have ones with one variable, right, which is kind of like an equation that you need to solve, right? Sometimes we have like x squared minus 2x equals 1, right? There's only one variable, which is x, right? And we just solve for what x equals. So in this case, even with an inequality, you could have one variable, and you solve it the same way you would solve a normal equation with one variable. Figure out what x equals. It's just that in this case, right, when you have a not equal to sign or an inequality, then you have lots of different answers, not just one or two single answers. You have like a range of answers. Okay. So, for example, all right, let's look at this problem. Say we have x squared minus 3x plus 3 is greater than or equal to 1. Okay, so the way we typically would solve this, right, is pretend that it was an equal sign and just solve, right? So we've got x squared minus 3x, bring the 1 over, so we've got plus 2 is greater than or equal to 0, right? Pretend it's an equal sign for the moment. Then we take this part and either complete the square, factor, use the quadratic formula, however you normally solve quadratic equations. Now in this case, I'm noticing that, hey, negative 2 times negative 1 equals positive 2, and they also add to negative 3. So I'm going to actually factor, because that's my favorite method as long as it's factorable. So I take that and let's factor it. So I've got an x minus 2 times x minus 1, and that's greater than or equal to 0. Okay, so then we need to figure out, okay, well, what are the actual solutions, right? So what helps is if you make a number line, right? And because typically we would take this and set it equal to 0, x equals 2, and x equals 1. But the problem is we don't have an equal sign here, so it doesn't work exactly the same way. Those are like our critical points, and we need those points, but we can't just say x equals 2 and x equals 1. So what I like to do is, I'm very visual, so I like to draw a number line. So I say, okay, well, all my numbers have to be, in this case, all my answers have to be real. So I make a number line with, negative 1, 0, 1, 2, and 3. Okay, and then I take my point x equals 2 and x equals 1, and I label those on my graph. So x equals 2 is right here, and x equals 1 is right there. Okay, and so essentially what's going to happen is I'm either going to get that all the values, that all the values above 2 and all the values below 1 will work, or I'll get that the values in between 1 and 2 work. Okay, so basically what you want to do is you want to pick points on either side of 1 and 2 to figure out what works with the original equation or inequality. So I can either go back to my simplified equation or inequality, which is this guy, or I can go back to the original. Doesn't matter, they're the same, right? And so what I do is I pick a value to the left of my critical values. So like I might pick 0 because that's an easy number to calculate. So when x equals 0, I want to check out what happens. Okay, so I have basically I'm taking this inequality and I'm plugging in, oops, I carried over a couple other things too, and I'm plugging in 0, x equals 0, and I want to see is it a true statement or is it not a true statement? Okay, and so when I plug in 0, I get 0 minus 2, which is negative 2, and 0 minus 1, which is negative 1. Is that greater than or equal to 0? That equals positive 2, which is in fact greater than or equal to 0. Hey, that's cool. Okay, so that means that the numbers to the left of 1 are going to work. Okay, so when you're graphing your solution, you're looking at all the values. I'm having some major issues today. So right, all the values that are less than 1 will work, right? Since it's an equal to sign, right, greater than or equal to, that also means that 1 works as well. So we would shade in a closed dot at 1 just because that shows that 1 is a solution as well. And you can check that, right? If I plug in x equals 1, I have 1 minus 2 times 1 minus 1, which is 0, and 0 is greater than or equal to 0. So it is a solution, right? So then we move on to something in between 1 and 2. If it's a quadratic, it's always going to be symmetric, so I can guarantee you that it is going to be the right of 2, but you want to just double check that. 2 will also be a solution, okay? But I recommend checking something in the middle, so something in between 1 and 2, maybe like 1.5, and see what works. See if it works or doesn't work. So let's actually try that. So let's plug in 1.5. If x equals 1.5, then I have 1.5 minus 2, 1.5 minus 1. So then I have a negative 0.5 and positive 0.5, right? A negative times positive is a negative number. Doesn't really matter what it equals, right? Because it is supposed to be greater than 0, but it's not. It's less than 0. So that's a fail. That doesn't work. So that means numbers in the middle, in between 1 and 2, right here, don't work. Okay, and then you can try something above 2 as well. Try 3 when x equals 3, just to be sure that it works. Okay, 3 minus 2 times 3 minus 1, well, that's 1 times 2. Those are both positive. It will be greater than 0, so that works, right? So then you shade the rest. Okay, so basically all of my solutions are any values of x that are less than or equal to 1 and all the values that are greater than or equal to 2. Okay. Also, if you're dealing with an inequality, right? If it's a less than or equal, or a less than or a greater than symbol, right? You're going to be using an open dot on those critical points because that means that it can't actually equal those values. And when you have a less than or equal to symbol or greater than or equal to symbol, you use a filled in dot because that basically means that you can actually equal that value. Okay? So that's for one variable. Okay? For two variables, right? Basically this is going to end up looking like a parabola, right? This is going to look like the parabola y equals x squared minus 3x plus 2. Okay, and so you could actually just plot the parabola. In this case, I know the zeros. I know it's concave up because a is 1. It's positive. I know that the zeros are, because I already found them, are 2 and 1, right? So my graph looks something like this. Here's 1 and 2, and I know it's concave up, and it has to go through positive 2 because of my y-intercept here. Okay, so my graph looks something like that. Okay, but in this case, we have an inequality, right? And basically, this inequality says that y has to be less than the parabola, right? And so if, I mean, again, you could probably just like pick a few points and see what works. So like if I want to pick the point outside the parabola, 0, 0, I want to see, does that work in my inequality, right? So I would have 0, is 0 less than, we don't know, okay, is 0 less than 0 squared minus 3 times 0 plus 2. Is 0 less than 2? It is. So that works. Okay. And that actually means we're shading wherever that 0, 0 point was, we shade below like where that point was, right? And that kind of makes sense because you're saying y is less than the parabola. So anything, so here's my parabola, anything less than that or below it, you shade, right? That'll work. So the only other thing that you gotta remember is that since this is a less than, it means that any of the points on the parabola don't actually work. And so you gotta demonstrate that with a dotted line instead of a solid line. So that would be how I graph that parabola, the inequality. So just keep in mind that if you have a less than or greater than, and you have you're graphing the parabola, you're going to have a dotted line, and if you have a less than or equal to, the parabola will be a solid line. Okay, so I think now there's a couple examples of graphing inequalities. So you can go ahead and try these. I'll do like a few examples, and then I mean that's kind of basically it. Alright, so let's graph that first one. Y is greater than negative x plus 1 squared plus 5. The nice thing is this one's in vertex form, so we know what the parabola looks like, right? That negative means it's upside down, it's flipped across the x-axis. The negative, the plus 1 on the inside, means it moved left 1 and up 5, which means my vertex is negative 1, positive 5. Right, so on my graph here, negative 1, positive 5. I'm going to make this a little thicker. Okay, that's my vertex, and I know that it's facing down. Okay, so kind of looks something like that, right? And the problem says y is greater than this parabola. So where is the area that's larger than the parabola? Well, it's everything above it, right? So you would just shade everything above the parabola would be your solution. And the only thing I have left to do is figure out, do I have a dotted line for my parabola, meaning that the parabola itself doesn't work as a solution, or do I have a solid line, right? And because it's a greater than, not a greater than or equal to, it's got to be a dotted line, right? And basically, like, if you're really not understanding what that means, it's like this half of the equation, right, that negative x plus 1 squared plus 5, that is that actual parabola, y equals that, is not less than this. So anyways, it's a dotted line. And that would be my graph. And that's all I have time for. So Ask questions in class if you got them. Okay, bye.